Eric Burgess here, and we've been given the following question. 6 gift cards worth $95 each are to be awarded to 6 attendees. The total number of attendees is 70 people. No one can win more than one. How many ways can the 6 gift cards be won? So you go to this conference or meeting or whatever, and they've got these pretty slick gift cards you want. And you're one of 70 people. Like that's not bad odds compared to how this normally goes down. So you want to see, how many ways can these things be distributed to all these different people? And it's important to know that no one can win more than one. So you can't, once someone's won, they're taken out of the equation. And this is important for permutations, combinations. Because if someone could win more than one, that's like having a repeating number of objects. Which would be a problem for how we're going to approach this. So looking at this, we say, okay, well, we've got 6 different gift cards, and we've got 70 people. So the gift cards themselves aren't unique. So that was to mean if you were to, let's say that your name gets picked. See, there's 6 gift cards. 1, 2, 3, 4, 5, 6. There's 6 spots. These are the winning spots. And if you won the first time, you get $95. But if you also won, let's say that you didn't get picked the first time. I'm just pretending you're like the 6th person. Let's say that you won over here. Well, you still get $95. It's no different. Where in some contests, the order you win could matter. Maybe it's 95 and the next prize is only $15. And then the next prize is 2. By the end, it's like $1. You'd really want to be the first guy. So the order would matter. And that would be a permutation question. But here, since the order doesn't matter, all the spots are equal, you don't care when you get picked, so long as you get picked. And this is important because consider this. Let's say that, person 1, 2, 3, 4, 5, and 6, right? You get picked here in the last spot, you still win. And if you were picked here, 6, 1, 2, 3, 4, 5, it's the same 6 people. All these people win the exact same thing. There's not like a unique prize. So the order of these people, it doesn't matter. So remember in permutation, we had n factorial over n minus r factorial. And we talked about in the last question why this formula works. Well, at the end, we just tack on, we want to remove this extra variation because we can swap any of these people with any of the other people and it would make no difference to who won what. They'd all win the same stuff still. So we need to divide out these extra combinations of people. So we put an extra r factorial there to remove all those extra combinations that would occur. Otherwise, it makes it look like there's a bigger number of ways than there actually is. We need to take out all those repetitions. So this is actually the formula for combination, NCR. And so using this, and once we've noticed this, and once I highly suggest coming up with some sort of way of looking at the problem like this. It'll make it a lot easier to tell if it's a permutation, or a combination problem. So looking at this, we say, okay, well, how many people are there? Well, there were 70 people that could be there. So that's 70 factorial. And then on the bottom, of those 70 factorial people, we're going to take out, because this is like everyone winning. That's just not going to happen, right? The winners, we're going to divide out all the people that would have won. So we're going to do 70 minus 6 factorial. This is going to leave us with a big number that's going to divide this big number. Leave us with only the ways to win. But then there's still all the different ways these people can be shuffled around, right? And it would still be the same thing. So we take them out by including all the ways these can be shuffled around. And since there's 6 of them, there's r factorial ways, that's going to be 6 factorial. So to type this in the calculator, what we would do is first we'd type a fraction. However, we're going to run into a problem. 70 factorial is so big, it's going to have a problem calculating it. If we put in 70 and then we put in factorial, so we go to math, whoa. We go to math, probability, and then we choose factorial. It's going to tell us it's just too big. It's ridiculous. So we're going to need to simplify this up first a little bit before we do it. But we can try, I actually don't know if the NCR option will work. So we could put 70 and then choose math probability and then go to NCR. So we've told it what N is. N is 70 and R, that's 6. So we put down 6. And oh, it'll tell you right there. So if you're using NCR, that'll still work, no problemo. But if you try to type it in, it has a problem with 70 factorial. So what we have to do is we have to simplify it. So 70 factorial over, and then 70 minus 6, that's going to be 70 minus 6, what is that? 64. Well, what the heck, we'll put it in. 64. So we're going to get 64 factorial over 6 factorial. And what we can do is we can bring 70 down to 64 because factorial means times the number less than it, times the number less than it, right? So we could go 70 times 69 times, we're just writing the factorial out, 68, 67, 66, 65, 64. But we want to stop at 64, right? We don't want to write all of it. So what we're going to do is we're going to say, well, if we were to keep going, it would still just be 64 factorial. We just happen to stop at 64. Now this lines up really nicely with this 64 factorial, and they simplify away. And we're left with this on top and this on bottom, which we can put in the calculator. Now you can actually simplify the 6 factorial too if you want and do some divisions here. You could write the 6 factorial out and then divide with the things on top. But I'm going to stop here. And I'm going to go to a fraction. So I'm going to hit alpha y equals, type of fraction, put 70 times 69 times 68 times 67 times 66 times 65. There's actually a really convenient way to write this as well using permutation, but I'm going to leave that out for now. But if you're interested, if you leave a comment, maybe I'll explain it to you in the comments. Because you can actually skip writing this out too using the permutation notation. But if you're going to be allowed to use that, you might as well use combination notation anyways. So we're going to do 6, and then we're going to do probability, factorial. We enter, and look at that. We get the exact same thing, and we've sidestepped the issue with 70 factorial being so big. My guess is in the programming for NCR, they probably do this simplification first, where when we type it in the calculator, it doesn't do that simplification first. It tries to compute this massive, massive number and then divide it by another massive, massive number. So that's just a problem all around. So if you're doing it by hand using the formula, which I know some professors require, you're going to need to get good at this kind of manipulation. It's going to come up actually more often than you think because factorials grow really fast. So our answer would be that there's 1, 3, 1, 1, 1, 5, 9, 8, 5 ways. I'm going to just put GC. So when there's 1N or 2, you know what? Whatever. Doesn't matter, okay? You know that we know what this means. So that's how many different ways we can pick the 6 winners for the gift cards. Now, some teachers are chill with you just writing, you know, the number in like ways at the end. But adding on, you know, what exactly it is important because it shows you understand what you're computing. So when it comes up in real life, you actually sort of know, hey, I can solve this problem using these techniques, and this would be what the answer means. If you have any questions, let me know. Subscribe and hit that bell icon for future videos, and we'll catch you in the next problem.